Okay, so now we're going to return back to piecewise functions and examine a little bit more about limits. So for the limit as x approaches negative infinity for this function f of x, we'll look over here and see what f of x approaches when x is really small. Well, as you can tell here, there's a horizontal asymptote, and basically what happens to f of x is that it approaches 3. So our limit as x approaches negative infinity is 3. On the other hand, when the limit as x approaches infinity for positive infinity, we notice that it also approaches 3, even though it keeps hitting 3. A horizontal asymptote does not necessarily mean that f of x cannot equal that value y. It just means that it gets really close to that value of y. So over here, as x approaches infinity, f of x also approaches 3. So that again is our horizontal asymptote. Keep in mind that the horizontal asymptote is not necessarily the same for the negative as x approaches negative infinity and x approaches positive infinity. Now moving on to the limit as x approaches 1 from the negative side. Well, over here you notice that the function goes up to infinity, so our limit is equal to infinity. This is known as a vertical asymptote, and also it's known as an infinite discontinuity because you cannot replace one value and make this function continuous. Similarly, on the other side, as x approaches positive 1, f of x approaches negative infinity, because as you get super close to 1 on the positive side, the values become more negative and there's no limit. When the limit can be represented as infinity or negative infinity, sometimes the answers for a multiple choice question will not give you infinity or negative infinity. In that case, there's often a choice that says does not exist because it's technically not one number, because infinity is not one number. Now, as the limit as x approaches 3 from the negative side, we can tell from this graph that it approaches 5, because as long as x is not equal to 3, this part of the function is approaching 5. Now, as the limit as x approaches 3 from the positive side, we can tell that it is approaching the y value of 2. So notice how these two limits are different. That means that the limit as x approaches 3 for the function f of x does not exist because it has to approach one number in order for it to be, the two-sided limit. In order for the two-sided limit to exist, the two one-sided limits must equal each other, which in this case is not true. And lastly, the limit as x approaches 0 is equal to 5. This function is continuous as x equals 0. So I think it's pretty clear that the limit as x approaches 0 is equal to 5.